Hi everyone, welcome to my channel. In my last video, I explained about the Pascal's triangle. If you don't know what I'm talking about, then do watch the video of Pascal's triangle first and then come back to this one. Because in this video, I'm going to explain how to expand a binomial by using the Pascal's triangle. So this is my Pascal's triangle, 1, 1, 1. This whole thing, this triangle is called the Pascal's triangle. And this is my binomial x plus y to the x plus y. Now, why is this a binomial? It's because it has two expressions that's connected by a plus sign. It could be a negative sign as well. So as long as you have two terms connected by a plus or minus sign, that's called a binomial. Now we will go to the first row and we will start from here. Now for the first row, we write n equals to 0. So if my n is 0, I'm going to substitute x plus y to the power of 0. This will just give us 1. Okay, this is simple. The next row is row 1. So x plus y to the power of 1 will give us x plus y. Now, what about this row? N equals to 2. So what does it give us? X plus y to the power of 2? Please don't tell me this equals to x squared plus y squared only. I'll be seriously mad. So this does not equal to x squared plus y squared. This means you have to multiply x plus y 2 times, like x plus y times x plus y. And if you expand this by multiplying the terms, you will get this equals to x squared plus 2xy plus y squared. Now if you look at the triangle, you can see that these numbers 1, 2, 1 are the same as the coefficients of these terms. So the first one, you don't have anything, that means the coefficient is 1. Then you have 2 and then you have 1 again, which is the same thing as this one. But what about the powers of these terms? So you start with x and with the highest power, x to the power of 2. Then for the next term, the power of x is 1. Then for the last term, the power of x is 0. That's why it's gone, because anything to the power of 0 is just 1. So I didn't write it. What about the second term? For the second term, you start with the opposite. You start with y to the power of 0. That's why the y is not there, because anything to the power of 0 is 1. So I didn't write it. The term after that, you have the power of y increases by 1. So 0, 1, and then 2. The power of y is 1. So this is how you can expand something without multiplying it every time. Let me show you another example. For this, the n equals to 3. So x plus y to the power of 3, what does this equal to? This means you multiply this whole thing, because x plus y to the power of 2 times x plus y again. So if you take this term, everything over here, and then if you multiply, distribute, you are going to get x cubed plus 3x squared y plus 3xy squared plus y cubed. Okay, now let's compare these numbers with this. So now I have, what numbers do I have in this row? I have 1, 3, 3, and 1. Now let's look at this. The coefficient is 1, 3, 3, and 1. But what happened to the terms? The first term was x, so I started with the highest power of x, that is 3. After that, I started reducing the power by 1. So this is 3, then 2, and then you have 1, and then you have x to the power of 0. That's why it's not there, because anything to the power of 0 is just 1. And for y, you do the opposite. So you start with y to the power of 0. That's why it's not there. Then y to the power of 1, y to the power of 2, and y to the power of 3. So you don't have to multiply this every time. You can just do it if you know how to find the numbers in the Pascal's triangle, and you change the powers accordingly. I will show you another example over here so that it's like not very messy. I will take this term. For this row, the n is 5, because this was 4. This is 4. So if your n is 5, this is going to be x plus y to the power of 5. Now let's expand this over here. I'm going to write x plus y to the power of 5. So this is how I write it. I will write the coefficients first this time. So what numbers do I have for this row? I have 1, then I have 5, I have 10, I have 10, then I have 5, and then 1. Okay, I think I took a lot of space. I didn't need to. Anyways, so I start with the first term with the highest power. So x to the power of 5. Then I will have x to the power of 4. Then I will just decrease the power by 1. So x to the power of 2, x to the power of 1, and then x to the power of 0. Then I will start with y. I'll do the opposite. So I will start with 0. Y to the power of 0, y to the power of 1, y to the power of 2, y to the power of 3, y to the power of 4, and then the last term is y to the power of 5. Then I'm going to add all of these expressions with this sign. Okay, now let's simplify it. So anything to the power of 0 is 1, so it's just gone. Then I have x to the power of 5 plus 5x to the power of 4 times y plus 10x to the power of 3y squared plus 10x squared y cubed plus this one is 5x y to the power of 4 plus the last term, it's gone, so you just have y to the power of 5. So you can see how easy it is to expand a term like this, like to the power of 5 or 7 or 6, just by using this Pascal's triangle. So that's why it's so important to remember the numbers. And if you want to expand it without using a calculator, you can just do it like this. All you need to do, just find out the coefficients first, and then for the first term, you start with the highest power, you keep on decreasing the power by 1, and then for the second term, you do the opposite. Okay, so you don't have to draw the triangle. Every time you expand a binomial, there is another way of doing it by using the calculator. So if in paper 1 you are not allowed to use a calculator, so in that case you can do it by using the Pascal's triangle. But what if you want to use the calculator in paper 2 and you have to expand a term that's x plus y to the power of 11? Or if you just want to find one term, like the 4th term or the 5th term, how to do it without expanding this every time. Okay, so take your scientific calculator. Do you see the button NCR, this thing in your calculator? N means the number of row. So my N is the number of rows, and the R means the number of term. I'm just writing it down so that you can remember this easily. Then I'm going to use the same example, but I'm going to use a different way of doing it. So let's see how to do that. So if I want to expand x plus y to the power of 5 without using a Pascal's triangle, this is what I'm going to do. I'm going to use NCR because this gives me the number of rows and the number of term, and you can find that coefficient exactly. Okay, so let's start. This is the general form. So when you want to write the first term, you start with this NCR. But what is going to be my N and R? If you look at this row, the N for this is 5. So I'm going to start with 5, then C is the combination, and for R, again, remember for row, we started with N equals to 0. Even for R, I'm going to start with 0. So this is going to be R equals to 0. This is R equals to 1, R equals to 2, R3, R4, and then R5. So this is my N. So the question is, how can you find these numbers by using a calculator? You just need to write it in this form. So for the first term, it's 5C, 0. And then you take the first term x and you subtract N minus R. So that's going to give me 5 minus 0. For the second term, I just take this value, the R only. So y to the power of 0 plus Then for the next term, the row stays the same. It's going to be 5 every time, but I'm going to change the value of r. So this is going to give me 5c of 1, then x to the power of 5 minus 1, because 5 and minus 1, and then y to the power of only this 1, plus 5c 2x to the power of 5 minus 2 times y plus y2, and then I will have 5c3 x to the power of 5 minus 3, and then y to the power of 3, almost there. Then 5c4 x to the power of 5 minus 4, and then y is 4. Now the last term, it's 5c5 x to the power of 5 minus 5, and then y to the power of 5. Now let's simplify this. Now you can use your calculator. Just write 5 and then use the button NCR and then write 0. 5c0, you will get 1. So this will give you 1 times x to the power of 5 times y to the power of 0 is also 1. Plus, if you type 5 NCR 1, you will get 5. So this will give me 5x to the power of 4 times y plus 5c2. If you put it in the calculator, you will get 10 x to the power of 3 y to the power of 2, and then plus 5c3. If you put it in the calculator, you will get 10 as well. So 10 x to the power of 2 y to the power of 3 plus 5c4 will give you 5 minus 4 is just 1, and then y to the power of 4 plus 5c5 is just 1, so this will give you 1 times x to the power of 0, which is just 1, and then y to the power of 5. So you don't really need to write it. This will give you x to the power of 5, which is, if you note that this is actually the same thing as this one. So x to the power of 5 plus 5x to the power of 4y plus 10x 3y squared plus 10x squared y cubed plus 5xy to the power of 4, and then the last term is y to the power of 5. So if you have a choice of using the Pascal's triangle or the calculator, it's up to you how you want to do it. But if it's with a calculator, you can use it, and if it's without a calculator, you can use this method. It's up to you, whatever it's important. So the general form of this is how we write it. It's NCR, and then the first term to the power of n minus r times the second term to the power of r only. Okay, now let's do another example without using the Pascal's triangle. Okay, so let's expand x plus y to the power of 4 without using our Pascal's triangle. So I'm just going to use, I don't have triangle, I'm not looking at it at all, so I'm just doing it with the calculator. This will give me, it starts with 4, that means the row is 4. I'm going to start with 4c0. Then x to the power of, x is the first term to the power of n minus r, which is 4 minus 0 is just 4. Then second term is y to the power of r, which is 0, plus 4c1, you are just going to increase it, x to the power of 4 minus 1, that will give you 3. Then the second term is y to the power of 1, because this equals to r every time. See, second term to the power of r. Then 4c2 x to the power of 2 y to the power of 2, then plus, I'm going to write it here, 4c3 x times y to the power of 3 plus 4c4. You know you have to stop when you have the same number. So 4c4, that means this is my last term, x to the power of 0, which is just gone, and then y to the power of 4. Now you can use your calculator. 4c0 is just 1. So 1 times x to the power of 4 times y to the power of 0 will just give you x to the power of 4. Plus 4c1 is 4. X to the power of 3 is just that, and then y. Plus 4c2 will give you 6. X to the power of 2, y to the power of 2. Plus 4c3 is 4. So you can write 4xy to the power of 3. Plus 4c4 is 1. 1 times 1, it's gone. So all you have left is y to the power of 4. So this is just another way of expanding it by using a calculator. Okay, now what if I want you to evaluate this without using a calculator, but you are not going to use the Pascal's triangle as well? So the rule is, if you want to find NCR, this actually equals to n factorial over r factorial and then n minus r factorial. Okay, now what is this thing? Let's say I have this 5C2. Okay, 5C2, what does it mean? Number of rows is 5 and you want to find r equals to 2. Okay, so the second term. Now also remember, the first term, it's called term 0. So let's find it. 5C2, how to do that? So according to this formula, I will start with 5 factorial over r factorial, which is just 2, and then n minus 1 is 5 minus 2 factorial. Now how to calculate it? This equals to, factorial means like you multiply all the terms that's after it till 1. So if I want you to find 5 factorial, that means you have to find 5 times 4 times 3 times 2 times 1. 2 factorial means 2 times 1. And then you have 5 minus 2, 3 factorial. 3 factorial means 3 times 2 times 1. Now you can cancel these things out. It's gone. Then 4 over 2, this will give you 10. Now if you look at the Pascal's triangle, let's look at 5C2. We did 5C2. Here, this is my 5C2. So you can see that 5C2 equals to 10. Now, why do you need to use it? So sometimes you will be asked to find a term that is, you don't have to expand the whole thing. You just want to find the 6th term or the 7th term or like the 10th term of one expansion. That time you use this formula, n factorial over this r factorial and n minus 1. So you don't have to draw the Pascal's triangle. You don't have to use the calculator. You can just do this to find the exact term. So I will show you one last example for the day just by using this format. Okay, so let's expand something that is a little bit different. Let's expand 2x plus y to the power of 4. I promise this is the last question for the day. So this equals to, you can also write it like this in r instead of writing NCR. So I'm going to write 4, 0 because the first term is 4C0. So 4, 0 and then 2x. Remember, the first term is not x anymore. It's 2x. To the power of 4 minus 0 is just 4. Then y to the power of 0 plus 4, 1. Then 2x to the power of 3, y to the power of 1 plus 4 over 2. The n is 4, r is 2. 2x to the power of 2, y to the power of 2 as well because the r is 2 plus, oh god, this is so long, 4, 3, 2x to the power of 1 and then y to the power of 3 plus 4, 4. This is the last term. That means it's time to stop. 2x to the power of 0 and then y to the power of 4. Now how to do this without a calculator? Let's see. So for the first one, 4 and 0, how to calculate it? 4, 0. This equals to 4 factorial over 0 factorial times 4 minus 0 factorial, which is 4 factorial. So 0 factorial is 1. So this gets is just 1. Then 4 and 4, it's also 1. That means the first term, that this equals to just 1. Okay, so this is just 1. Okay, let me just erase it and let me do it here. Then I will calculate 4, 1. How to do it? Again, 4 factorial over 1 factorial times 3 factorial. 4 means 4 times 3 times 2 times 1 over 1 factorial is just 1. And then 3 means 3 times 2 times 1. So you can cancel all of this out. All you have left is 4. This equals to 4. Then you have 4 over 2. This equals to 4 factorial over 2 factorial and then 2 factorial. How to calculate it? 4 means 4 times 3 times 2 times 1. 2 is just 2 and 1, and then 2 and 1 again. 2 and 1, 2 and 1 gets cancelled out, and then you can divide this, so you will have 6. So this equals to 6. Okay, then I have 4 and 3. This equals to 4 factorial, 3 factorial, and just 4 minus 3 factorial is just 1 factorial. Now it's just easy because you know 3 is 3 to 1 already, and then for 4 you have 4 3 to 1 also. So you can actually cancel out this 3 and just write 4. So this equals to 4. And 4 and 4, it just means 4 factorial over 0 factorial, which is 1, and then 4 factorial again. This will give you 1. So this equals to 1. Okay, now let's expand this. This will give me 1 times 2 to the power of 4. 2 to the power of 4 is 16, so it's going to be 16x to the power of 4 plus 4 times 2 to the power of 3 is 8. 8 times 4 is 32, x to the power of 3, and then y, plus 6 times 2 to the power of 4 is 24. So 24x to the power of 2, y to the power of 2, plus this one as 4 times 2, because the power is just 1. It's 8xy to the power of 3. Then plus the last term, everything is 1, 1. Y to the power of 4 is just y to the power of 4. So this is my final expansion. This was not long at all. Okay, so that will be all for today. In the next video, I'm going to practice more examples of binomials that can help you with the IB exam. Okay, so that will be all for today. Thank you for watching. If you like my videos, then don't forget to subscribe. See you next time. Thank you.